Hi friends, welcome to follow up. Let's have a look at problem 63, unique path 2. This is today's daily challenge problem. So here we are going to solve this problem using dynamic programming. So here we are given a m by n grid, and there's a robot. It can only move to the right or downwards. So we want to find the number of possible unique paths that the robot can take to reach the bottom right corner. So here are two examples. So in the first example, due to the obstacle in the middle, so there are two ways, either this to the right and to down, or downwards and then to the right. So in the second example, so there's only one way due to the obstacle in the top right corner. So the output is 1. So here the problem size actually is not very large because m and n are both bounded above by 100. So with that said, let's look at the code. And in between, we're going to explain the logic. So for this problem, actually we can directly translate the logic into code. So first I'm going to get the dimensions. So grid and grid 0. So m is the number of rows and n is the number of columns. And then we are going to initialize a dp table. So 0 times n for a gamma index in range m, right? So this dp table, dp, is an m by n grid or matrix. So first let's set the 0, 0 element, right? So this one is going to be 1 if grid 0, 0 is not 1, so right? In other words, it's 0. Otherwise, so it's going to be 0, right? Or you can just ignore, right? So because you can see if this is 0, then we set this to be 1. So with that said, what we are going to do next is to first set the first row of the dp table, then the first column, and then we do update for the generic cell. So let's see, initialize the first row, right? So here we iterate for j in range 1 to m, right? So first we want to check if grid ig is obstacle or not. If it's an obstacle, then this position, so here is, let's use 0, right? So we're going to set the dp 0j to be 0, right? So actually the cell after this position j in the first row will also be 0, right? So otherwise what we are going to do is we are going to set this dpj equals dp0 j minus 1. So this set up the first row. Now let's set up or initialize the first column. Actually same logic, right? That for I in range 1 to m, right? Then if grid I0 is 1, right? Then we're going to set dpi0 to be 0 because it's an obstacle, there's no path ending at here, right? In other words, the dpij is interpreted as the number of passes, valid passes ending at the position ij, right? So this is the one. Otherwise, if it's not an obstacle, what we are going to do is I0 equals dp I minus 1 0, right? So here for these two for blocks, so we start j from 1 and we start I from 1 also. Therefore, the j minus 1 here and the I minus 1 are both greater than or equal to 0. In other words, inbound. So with that said, let's look at the generic case or generic cell. So for I in range 1 to m. So for j in range 1 to n, right? Then again we take the same logic. Let's check if this position is an obstacle, then dpij shall be 0. Otherwise, this is the main logic. So here we can arrive this position from two possibilities, either from up, right, that is dp I minus 1g, or from dp left, that is dp I and g minus 1, right? So here we do sum this due to the interpretation of dpij. In other words, the number of valid paths ending at this cell, right? So then what we're going to do is we're going to return dp -1, -1, right? So this actually forms a solution format. So here we wrote this code actually with some redundancy. For example, we initialize this dp with all zeros, and for some tests, some cases like here, we do not need to set. We just need to check when dp 0g is not 1, then we just reset this guy, right? So similarly here, but we wrote in such a format. The purpose is to make the logic clear. So with that said, let's first do a test. It passes the first example. Now let's look at the generic case. It passes all the generic cases. So I would say that this problem is a very straightforward or simple one if you have practiced a large number of DP problems. So basically here we just present the logic, and it's for sure that you can optimize or shorten the code. For example, we can just use a nested for loop to include all the logic in between, right? So with that said, that's about it for this daily challenge problem. Thank you.